All right, so for our notes today, we're going to be talking more about probabilities in the normal distribution, but last class we talked about probabilities where we were only interested in numbers that fell exactly on a standard deviation. So, for example, if the mean was 60 and the standard deviation was 5, I was only asking you for probabilities that were exactly landing on a standard deviation. Like one standard deviation above was 65, two standard deviations above was 70. But say, for example, I needed to know the probability it was less than 66, which doesn't land on one of those. This is not linear, okay? So there is no like linear equation that we can use to figure those out. There are things called z-scores, which help us determine where we are on this curve. And there's something called a z-score table. You can look one up and look at it. Often we teach these probabilities using a z-score table, and I can show you how to use that if you're interested. However, Desmos does a lot of the heavy lifting for you. So we're going to be using Desmos today. When you do your homework assignment, there's like a statistics calculator embedded in it. If Desmos works for you, I'm going to suggest using Desmos just as practice, because when you do your quiz for this unit, you'll be using Desmos and not the Delta Math statistics calculator. So it's just good to practice using the thing you would use for testing. However, if it's like giving you some errors to the thousands place or something, then you can go back and use theirs. I think it'll be fine though. I think that as long as you're rounding correctly, you'll be able to use either calculator. This is just a little reminder of notation. We usually use the mu for mean and the sigma for standard deviation, but you might also see these symbols here. So right here, we're talking about how to find a z-score, and this is telling you what a z-score means. If you determine that a point has a z-score of 1, that just means that it's one standard deviation above the mean. If it was like 1.1, it means it would be just like a little bit past one standard deviation above the mean. So z-scores can be used to compare two things that are on different scales. For example, say you took the SAT test and your brother took the ACT test, and you know that you both scored above average, but you can't really tell who scored better. If you found a z-score for your test and for your brother's test, you could compare those two to decide who did better on the test. And colleges can do that too. All right, so this is a formula to determine a z-score. It's going to be your number minus the mean divided by the standard deviation. And so we're going to look at an example down here. All right, number 1, if you have normally distributed data that has a mean of 10, so 10's in the middle, and a standard deviation of 3, so each of these lines is going to be 3 above or 3 below 10. If you have a data value of 16, so say it was like a quiz, and the mean for the quiz was 10 and the standard deviation was 3, if you got a 16 and you wanted to know your z-score, you can use this formula. The 16 is your x, that's your score. The mean is 10 and the standard deviation is 3. And so we just substitute into this formula. It is a very simple formula. 16 minus mean 10 over standard deviation 3. Okay, so your z-score is 2, and that means that you are 2 standard deviations above the mean. So if you look at the normal curve here and you look at 2 standard deviations above the mean, you can see you did better than a lot of people. The only people that did better than you are over here, okay? You could use the empirical rule in this case that we used last class to add up the percentages and find what percent of people you did better than, but that's only because it landed exactly on one of those standard deviations. What questions do you have before we do the next one? All right, so I want you to try the next one. You have a new x value, and then you're going to use the same mean and standard deviation. All right, so my number is 5.5, and then minus my mean over my standard deviation. Is that negative 1.5? Okay. All right, so I cannot use the empirical rule to find the percent of people I did better than if I have a negative 1.5, because it's between these two values. And you can see, like, I can't just cut it in half, because cutting it in half, the right side is much bigger than the left side. So that's not going to work. But I will show you, because it is done in several courses, how you could use a z-score to find the percent that you're better than. So if I had a z-score of negative 1.5 and I wanted to know what percent of people I did better than, I would find negative 1.5 here, and it would be this number. If my z-score was like negative 1.52, then I would have to find the 0.02 at the top and line it up with the negative 1.5, and it would be this one. So negative 1.5, that means I only did better than 6.68% of people, because my probability there is 0.0668. You're not going to have to use the z-score table. I just wanted to show you because it is still used in a lot of math classes. All right, so these are the z-scores we found here. Let's do number 2. In number 2, it's interesting because they give us this like chart over here of student heights, but you'll notice they only labeled 2 standard deviations from the mean. I really like to see all 3 of them, so I'm just going to add another one. It says the standard deviation is 4, so that means over here I would have 80, and then back here I would have 56. All right, so student heights are normally distributed with a mean of 68 and a standard deviation of 4. Determine the z-score for a student with a height of 63 inches. So go ahead and do that. That's my x, that's my mean, and that one is my standard deviation. Yeah, I got negative 1.25. Let's see. Honestly, when I did these notes yesterday, I was super tired. So I keep asking you because I'm not feeling confident. But I did get negative 1.25. Are we good with that? Yeah. Okay. All right, so we got the z-score for a person with 63 inches. This one is telling us the z-score and is asking for the height. Did anybody start thinking about that one yet? You did, Steph? What were you thinking we could do? Mm-hmm. Well said. Well described too. All right. So like Steph, I'm going to put the 3.5 for the z and keep the x as x. So Steph, what did you do first? Okay. $14? Okay. And then what do we do? Add 68. And I'm getting 82. Can anybody confirm 82? Yeah? Okay. All right, and I think there's probably a unit on that. Let's see. Inches, right? All right, so x equals 82 inches. Yeah, so you can use a z-score to work backwards and find the student's height as well. All right, so we're on the back. The time a fire department takes to arrive at the scene of an emergency is normally distributed with a mean of 6 minutes and a standard deviation of 1.5 minutes. Use Desmos to set the problem up. So we need this command normal dist. You can find this command under functions in Desmos, or you can just type it. It's up to you. It says, what percent of 911 calls take less than 5 minutes to arrive at the scene of an emergency? So if it's less than 5 minutes, do we want negative infinity to 5 or 5 to infinity? Negative infinity to 5, because that would be all of the numbers up to 5. Isn't that pretty how they shade the graph for you too? I really like that. All right, so they tell you the probability is 0.25249. All of these numbers, we can definitely round it. In a testing situation, I would tell you what to round to. Let's use 3 digits for now. So on our paper, we're going to write a probability statement because we haven't had a lot of practice with that. And let me show you how to do that. We're going to write the probability that x is less than 5 is 0.25. It was 252, right? Mine went away. Okay, 0.252. And then we're going to use that probability statement to make a statement about the percent. So the percent of calls would be 25.2%. Okay, so 25.2% of calls take less than 5 minutes. So we can use this same calculator to find the percent of calls that take between 4 and 8 and the ones that take more than 8 minutes. So I want you to try B and C, and if you feel up to it, also try D using your same calculator. Okay, so I think most of you are ahead of me. If I want to find the probability it's between 4 and 8, I just change my min and max, and I'm going to get 0.81, and that one rounds up to 8, 0.818. So that's my probability, and then it asks for the percent, so it would be 81.8% of calls. All right, and then probability x is greater than 8. I'm going to go back in there. And that should be from 8 to infinity. I found that if you type the word infinity in here, it will give you an infinity. Has anybody found anything quicker than that?
You can just erase it.
Oh, just erase it if I delete it? That has nothing. Oh, there it goes back. Is that it? Yeah, nice, thank you. Okay. So 0.091. So 9.1% of calls. What questions do you have before we go on to D?
How to write the probability statement.
Okay. So let's see. This one says takes less than 5 minutes, so that's x is less than 5 minutes. And this one says takes more than 8 minutes, so that's x is greater than 8. And if it's in between, what we're really saying is 4 is smaller than x, and x is smaller than 8. So x, that's how we say that x is between the two numbers.
So it's never going to be like greater than.
Only if it's a single one like this, right? But not if it's in between. If it's in between, it's always going to be these symbols. All right, if 45 emergency calls are made in one day, how many would you expect to take more than 8 minutes? So I think some of you have already done this. You saw that it was going to be 9.1%, which as a decimal is 0.091. And you multiply that by 45 to find out how many calls are more than 8 minutes. So I'm going to do that too. So I'm getting about 4.1 calls, which is about 4 calls. Definitely for calls, you would round to a whole number.